Sixth graders, welcome to your science full revision video. In this video, we're going to use your Collins International Primary Science book, and we're going to start with topic 3, material changes. First thing we will do is defining matter. Matter is the scientific name for what things are made of, and it's found in different states. Take water here as an example. This is the solid state, this is the liquid state, and this is the gaseous state. Changing from one state to another is a reversible change. This means that the change can be undone to return the matter to its original form. Another example of reversible changes is dissolving. Take a teaspoon full of sugar and mix it in a cup of water. And when sugar dissolves in this water, you will not be able to see it anymore. But when you leave this cup of water in a warm place, the water will evaporate, leaving the sugar crystals behind. Therefore, I got the sugar back. That's why we call it a reversible change. While on the other hand, some changes are permanent and they cannot be reversed or undone. And an irreversible change usually produces new substances as a result of chemical reaction. Examples of irreversible changes, or what causes irreversible changes: crushing, breaking, burning, cooking, or fizzing generally produce irreversible changes. Let's take a look at this example over here. When a seed germinates into a plant, this is an irreversible change because I cannot get the plant back to being a seed. Next example is frying an egg. It's also an irreversible change. And another example is when I try to make some popcorn, I cannot get the kernels back. A mixture contains two or more substances mixed together but not changed in any way. Look at this mixture, for example, flour and raisins. When I want to separate these two mixtures, I can easily use sieving in this case because the small particles will fall off and the raisins will be left up there. Another example, when I have some sort of metals mixed together and I need to separate them, I can use magnetic separation to attract some materials or some matters and leave behind the other matters. Soluble substances dissolve in water and insoluble substances do not. A mixture of water and a soluble or insoluble substances can be separated. This is a soluble substance. Sugar is a soluble substance because it can easily dissolve in water, and this mixture can be easily separated. While some solids react with water and produce new substances, and when it happens, the change is irreversible. Look at this tablet over here. When it reacts with water, once it's dissolved, I cannot get it back. That's why we call it irreversible change. Next here, when soluble materials dissolve in water, they form a solution. So as we saw previously, the mixture was containing two or more substances mixed together but not changed in any way, while the solution is when I try to dissolve materials in water. For example, take this cup of water, add some sugar, dissolve it, and you will get a solution. Now, when I look at this cup, I might not think it's a solution because these two cups look very similar. And in order to find out which one is a solution and which one is just water, I can compare their masses because the sugar here will add some mass to the water. A suspension is a mixture of water and insoluble solids. For example, when I try to mix some paint with water, I will still be able to see the paint particles in the water. Therefore, we call it a suspension. Solids that have not dissolved in water can be separated from water by filtering. A filter is like a fine sieve that allows water to pass through, but which traps solid residues in the filter. A very easy example that we use every day in our lives is when I try to make a cup of tea. I use filtering in order to boil some water and drink some nice tea. Another example, when I separate pasta from boiling water over here. Now let's move to topic 4, forces and motion. And starting from 4.1, measuring forces. Now you're supposed to already know that an amount of push or pull is called a force, and the size of a force can be measured using a special instrument called the force meter. And the unit of force is the Newton. Take a look at the picture we have here for a spring balance. When you hang an object from it, the weight of the object pulls the spring down and stretches it. Objects have weight because the force of gravity pulls them towards the surface of the earth. And when you measure the force exerted by an object in Newton, you're actually measuring its weight. Now, in order to know the difference between a weight and a mass, remember that a weight is a force that can be measured in newtons and affected by gravity. So, an object's weight changes when gravity is stronger or weaker, while mass is the amount of matter in an object measured in kilograms and grams. And we use something called beam balance, like the one in the picture, to find out the mass of an object. And mass is not a force, and it doesn't change as a result of gravity. Now, let's study about movement and energy. Now we know that energy allows object to do work, and it allows us also to move our bodies, just like the objects. In addition, all moving objects have movement energy, which means they can do work as a result of the movement. Think about kicking a ball. Your foot moves to make the kick. The energy from your moving foot provides the force needed to start the ball rolling, and the ball then has its own movement energy that allows it to do the work of rolling. So, as a conclusion, movement requires energy, and all moving objects have movement energy. Now let's move to another force, which is friction. Friction is an invisible force that occurs when objects come into contact with each other. The objects that are in contact to each other here in the two pictures are the box and the ground. When two objects move past each other, they exert force on each other, and we call force that acts against or resists movement, we call it friction. And it slows down or even stops things from moving. Look at the example here. We need something called pushing force to make this box move. And this pushing force must be greater than friction in order to make this box move across the floor. In the other picture, the other boy, the pushing force he's trying to apply is almost equal to the friction. That means the box is almost not moving because of friction. So friction resists movement and slows down objects or even causes them to stop. Another force is air resistance. It's a sort of friction that acts to slow down objects that are moving through air. And when objects fall through the air, gravity acts downward, and air resistance acts upward to slow their fall. Now, friction is useful actually. It allows us to slow down speeding objects, prevents objects from sliding when putting them down on the surface, and it allows us to walk. But friction is not always useful, and we have to find out some ways to reduce friction. Why? Because it's very useful to reduce friction, to make movement easier and to lessen wear and damage to the moving parts. One way of reducing the friction can be through smooth surfaces, or using parts that roll instead of rubbing or sliding over each other, or adding oil, which makes a smooth layer between parts and allows them to move easily past each other. Now let's move on to topic 5, which is electricity and magnetism. Look at this circuit over here. We can draw this circuit using a diagram to represent it. And in order to do that, we need to use some conventional samples to represent the components and make it easier to draw. Around the world, scientists use these symbols: lamp, cell, switch, buzzer, and motor. So this circuit is going to look something like this. 2 batteries up here, 1 lamp, 1 motor, and 1 switch. Now let's study about the metals or the materials that allow electricity to pass through them. Some materials conduct electricity while others do not. Conduct electricity means they allow the electricity to flow through them, and we call them conductors. Examples of conductors in the picture: iron metal rod, copper metal wire, and silver metal chain. The materials that do not allow electricity to pass through them are called insulators. An example is the wooden ruler and the plastic pen. Other examples are rubber and plastic. They're considered as good insulators. In the picture here, the man is working using or wearing rubber gloves to protect himself from electricity. Now, some metals are called good conductors or are being good conductors of electricity. Examples: copper, silver, aluminium. And the reason why, because they allow the current to flow through them easily. While the others are called poor conductors, because as you can see, the electricity is not moving as easy as the first picture of the good conductors, and the electricity is facing a lot of obstacles. Now, one might think, okay, metals are good conductors, therefore they're used for cables and wires, but why do we use insulators, or how or when do we use insulators? Here's an example of an insulator, which is plastic. It's used to cover wires and plugs and to make switches because it's a good insulator and does not conduct electricity. Therefore, next time when you're thinking to plug in your charger to charge your laptop or phone, you're safe because the plug is being covered by plastic. Changing the number or type of components in the circuit affects the way the circuit works. Look at the difference between circuit A and the circuit on the left side. This is called a series circuit because all components are one after the other in one loop. While in this circuit, it's not considered as a series circuit because it has 2 loops. Therefore, the electricity would be different than in these 2 circuits. Another example is these 3 circuits, A, B, and C. Circuit A has 1 lamp and 1 battery. Therefore, it's burning a lot brighter than circuit B and C. And at the same time, circuit C has 3 lamps and 1 battery. Therefore, it's burning less brightly than both circuits B and A. Guys, this was a very brief overview of the lessons that were covered in science. I will see you next time with the revision questions in the next video.